Hey physics students, this is Mr. Resentis. I'm in chapter 2 and that's page 40 of your textbook. What I'm talking about today is motion in one dimension. Now, a change in position is really displacement from a point of reference to some other point, and that's called displacement. It can be negative or it can be positive. So the distance of that change, in position is called displacement. Right, and it could be negative or it could be positive. And change in position is usually delta x. So delta x in the numerator, and if you put that over delta t, and delta t would be time, change in time, change in position or displacement, the quotient is velocity, average velocity. Average velocity, right? And velocity has magnitude and direction. Speed only has magnitude. So if you're on a racetrack and you're going round and round and round and round and round, you have no velocity because you're right back where you started from, but you might have speed. So speed just has magnitude. Velocity has magnitude and direction. That's why velocity can be positive or it can be negative. So if you plot delta x, or displacement, on the y-axis and delta t on the x-axis, delta t is time, change in position, then you should have a straight line if there's constant velocity. Now, in this straight line, what we have is a constant increase in velocity. This straight line would be no velocity, and then in this case we have decreasing constant velocity. So the straight line means that we have constant velocity. Straight line equals constant velocity. If it's up, it's positive. If it's down, it's negative, or you have no velocity at all. If it's a straight line. If there's not a straight line, if the line is not straight, then then the velocity is not constant. So in this situation, we do not have constant velocity. But what if we want to know what the velocity is at any given point? Say we want to know what the velocity is here at this given point. So what we would do is we would call this point the instantaneous velocity. We just want to know what the velocity is at this point. And in order to find that instantaneous velocity, what you have to do is you have to find the slope of the tangent line. Here's the tangent line. And so you have to find the slope of the tangent line. You remember finding slope, rise over run. Well, Let's try a couple of section review questions. I'm on page 47, and I just want to try a couple of section review questions. All right, so really with this equation, all you have to try and memorize is a change in x, change in t, velocity, average. Here's the relationship. All right, and you remember this. If you want velocity, you divide change in x over change in t. I apologize. If you want change in t, then you have change of x over v. If you want displacement, you multiply. You see how they're right next to one another? You divide. I'm putting my thumb over that which I want. So let's try the first question. The first question here on page 47. What is the shortest possible time in which the bacteria could travel a distance of 4.8 centimeters across a petri dish at a constant speed of 3.8? So here, in this situation, we obviously want t. So if we want t, we just have to put x over constant velocity, right? Because the question is how much time, right? So so number one, 84 millimeters divided by 3.5 millimeters per second, or 24 seconds, and that is delta t. So remember, whichever one you want, you put your thumb over it and either divide, multiply.